Let's look at reactions of aniline. First, how to make it. We start with benzene, treat with sulfuric and nitric, that means nitronium mixture, and you will end up with nitrobenzene. So once you have nitrobenzene, you have to reduce that. So you can industrially use hydrogen and catalysts, or you can normally, in a laboratory setting, you will be using tin HCl and sodium hydroxide. It's a refluxing complex reaction, but it works well in a lab. Industrially, hydrogenation, catalytic hydrogenation, but in the lab, tin HCl, conc HCl, sodium hydroxide. So once you have it, aniline can donate these electrons and open ortho positions and para positions as negative. So that's an electron donating group. So it's a ortho para director. And also remember, nitrogen could be the nucleophile, that these three carbons on ortho para would be the electrophile. So that's the fundamental difference. You don't have to recognize the two, but you will end up with two different products for it. Now the most important reaction you can do actually is react with HNO2. Now HNO2 is not available, so you're going to do a sodium nitrite and HCl at low temperature, 5 to 10, you will get diazonium salt. So this diazo salt actually will remove a nitrogen gas and added many different groups and atoms, so you can do 10 different reactions with the diazoniums. That's the beauty of that reaction. Now you also can do acyl chlorides, but that one will react on the nitrogen, like I said, so it's not reacting on the benzene itself. The basic conditions just to remove the HCl from the NH2 group, and it will be attached to the nitrogen atom. So the nitrogen will keep one hydrogen, and acyl group will be attached to the nitrogen. So this is a reaction on the nitrogen. That's the difference, right? Now the third one, we are going to react with bromine water, bromine chloroform, CCl4 would work too. So what you will get is this tribromo compound. So this one is actually a precipitate, white precipitate, and you can do the similar reaction with chlorine. Now this one can be named as 2,4,6-tribromo aniline. Remember, chlorine gas also can be used in a similar fashion, end up with a similar product. Now number 4 is nitration on aniline. So now it's an ortho-para director, so we should be able to get ortho-para products, but the para is dominant. Try to draw the para-nitroaniline. Now, number 5 is, let's react with RX, that's a methyl bromide, something like that. And then what will happen, this one also will react on the nitrogen. So that means you will have amine instead of primary, it will be going into the secondary, tertiary, and tetraammonium salt up to. So this reacts under basic conditions, and then you will get hydrogens on the nitrogen replaced, ending up with the ammonium salt of it, right? Now, the last one is actually not happening. That's something important to know. Don't try to do Friedel-Crafts alkylation or acylation on the ortho, and para. It does not work. So all the other ones that I showed you about will work, but alkylation or acylation of Friedel-Crafts method do not work in this scenario. So what happens is instead nitrogen will react, giving different products.